Good morning, dear student. Today I am continue to the previous lecture. Now I am solving the differential equation with the help of Laplace transformation. Please you can note down the numerical. You can note down to solve the differential equation. The differential equation y double dash minus t y dash plus y is equal to 1 when y0 is equal to 1 and y dash 0 is equal to 2. This is right. Now you can note down, solve this problem, solution of this problem. We have y double dash minus ty dash plus y is equal to 1 taking Laplace transformation on both sides. You can write Laplace of y double dash minus t y dash plus y is equal to Laplace of 1. Now you can write Laplace of y double dash minus Laplace of t y dash plus Laplace of y is equal to Laplace of 1. Now you can put all the differentiate value of Laplace. First y double dash, this means s square y bar minus s y0 minus y dash 0 minus t means minus 1 d of ds. This means first time of derivative. Now you can write y dash, this means s y bar minus y0. Now again plus Laplace of y means y bar and Laplace of 1 is equal to 1 by s. Now you can putting y0 is equal to 1 and y dash 0 is equal to 2. Now you can write s square y bar minus s minus 2 minus plus bracket. This means differential of this function s dy bar upon ds plus y bar minus, this means constant, this is a 0. Now plus y bar is equal to 1 by s. Now you can put in s square y bar minus s plus 2 minus 2 plus s dy bar upon ds plus y bar is equal to 1 by s. Now you can write s square plus 2 y bar plus s dy bar upon ds is equal to 1 by s plus 2. Now again s dy of ds plus s square plus 2 y bar is equal to 2 plus s plus 1 by s. Now you can common to s square s, this means dy of ds plus s 2 upon s y bar is equal to 2 by s plus 1 upon s square. Now you can write dy bar upon ds plus s plus 2 upon s y bar is equal to 1 plus 2 upon s plus 1 upon s square. This is equation number first. Now you can write, you know that thus equation first is linear differential equation, then p is equal to, this is a p, s plus 2 upon s, and q is equal to, this is a q, 1 plus 2 upon s plus 1 upon s square. Now to solve the differential equation, linear differential equation, first we find if. If is equal to e to the power integration p into ds. Now you can put the value of p. This means e to the power integration s plus 2 upon s into ds. Now you can solve this problem. This is the integration of e to the power bracket. This is a s square by 2 plus 2 log s. Now you can write e to the power s square by 2 into s square. This means if is equal to s square into e to the power s square by 2. This is if. This means integrating factor. Now you can solve the solution of linear differential equation, y into if is equal to integral q into if into ds. Now you can put in the all value of this y into if. This means y bar. Now you can put in s square into e to the power s square by 2 is equal to q means integration of 1 plus 2 upon s plus 1 by s square into if means s square e to the power s square by 2 into ds. Now you can write this. Please you can note down. Since y into s square e to the power s square by 2 is equal to integral, you can multiply the function s square. This means s square plus 2s plus 1 e to the power s square by 2 into ds. Now you can solve this integrate. First you can note down s square plus 1 e to the power s square by 2 into ds plus integration 2s e to the power s square by 2 into ds. Now you can solve this integral. First we let s square by 2 is equal to t. Now you can write s is equal to root 2t. This is your resultant value. Now you can differentiate to this function. You can differentiate to this function. This means s ds is equal to dt. S ds is equal to dt. You can write. Now again, I have putting this value in this function. This means y into s square e to the power s square by 2 is equal to integral. You can write s square. S square means 2t. 2t plus 1 e to the power t into dt upon s. dt upon s plus 2 integration. The value of s is this means e to the power t into dt by dt. Now you can solve this problem. This is 2t plus 1 e to the power t into dt upon, this is a value of 2 root t. This means root 2t plus 2 e to the power t. T means s square by 2. S square by 2. Now you can write integration. You can multiply by this root 2 t to the power 1 by 2 plus 1 upon 2 t की power 1 by 2 root e to the power t into dt plus 2 e to the power s square by 2. Now again multiply root 2 integral t to the power 1 by 2 e to the power t plus 1 by into dt plus 1 by root 2 integration t to the power minus 1 by 2 into e to the power t dt plus 2 e to the power s square by 2. Now you can solve this integration by integration of part. First you can write this is a minus t. You can write this. This is a first root 2 integration e to the power t 1 by 2 into e to the power t dt plus 1 by root 2 integration t to the power minus 1 by 2 e to the power t into dt plus 2 e to the power s square by 2. Now you can solve this integral. You can find root t root 2 into root t e to the power t plus 2 e to the power s square by 2 or plus c1. Now you can put the value of this t. This means s e to the power s square by 2 plus 2 e to the power s square by 2 plus c. Now you can watch. Now you can write. This is rough. Right? You can write this. This means y bar into s square e to the power s square by 2 is equal to s e to the power s square by 2 plus 2 e to the power s square by 2 plus C1. Now you can write y bar is equal to C1 e to the power minus s square by 2 upon s square plus this is multiply. This means 1 upon s, 1 upon s. Now you can multiply of this. This means plus 2 upon s square. Now you can write this. Now you can write y bar is equal to C1 upon s square plus 1 upon s plus 2 upon s square. Now taking inverse Laplace transformation, Now you can write L inverse y bar is equal to into e to the power minus s square by 2. Now you can write L inverse of C1 by s square e to the power plus minus s square by 2 plus inverse Laplace of 1 upon s plus 2 upon s square. Now you can write y is equal to inverse Laplace of C1 upon s square e to the power minus s square by 2 plus inverse Laplace of 1 upon s plus 2 upon s square. Now y inverse Laplace of C1 upon s square, you can put this value 1 minus s square by 2 exponential function e to the power x. I can open now plus s to the power 4 upon factorial 2 into 2 now again plus dot dot dot. Now again you can write plus inverse Laplace of this 1 upon s plus 2 upon s square. Now you can write y is equal to inverse Laplace of 2 plus C1 by 2 s square minus C1 upon 2 plus C1 s square by 2 4 plus 1 by s minus dot dot dot. Now you can solve y is equal to inverse Laplace of 2 plus C1 by s square plus 1 by s minus C1 upon 2 plus C1 s square by 4 minus dot dot dot. If inverse Laplace of C1 by 2 and is equal to 0 and inverse Laplace of C1 s square by 4 is also equal to 0. Now you can write y is equal to 2c1 t plus 1 plus c1 c plus c. This is the solution of differential equation. Now you can write this is your final answer. This is your final answer. Please you can note down. If you have any problem to any step, please comments to my video and please also like and subscribe. Thank you.